Hey guys, Mr. B here, and this video we're going to go through the practice problems for the second part of Chapter 8, Section 2 on the nature of covalent bonding. So I've got my setup here, a little awkward, so I apologize if I'm trying to kind of reach my hands around my tripod and stuff here, but regardless, let's get into some practice. So number 6 here says, draw the electron dot structures for each of the following examples. So the first one we have is NH4+. All right, so we're going to switch to our paper so that we can take a look at doing this drawing, because again, it's really difficult to do this in Google Slides. All right, so you've got NH4. Again, I apologize if I bump my camera as I'm doing this. So we have NH4+. Okay, make sure this can be seen as well. Oh, I'm going to shift this down a little bit. There we go. Okay, so we got NH4+. So the first thing we should do is let's actually count how many valence electrons we have. So we have N, which usually would have 5 valence electrons. Okay, now I don't have a periodic table in front of me right now. You should have one in front of you. Okay, I know that there are 5 valence electrons in nitrogen because I've memorized it. But either way, nitrogen's in column 5 on the periodic table, so there's 5 valence electrons. Then we have 4 hydrogens, and each one, of course, is going to have 1 valence electron. Okay, however, we have this plus. Okay, this little plus thing. So that means that we have lost an electron. So we have, well, let's do this. We have 4 hydrogens. Okay, so total, if we count up all the valence electrons in here, we should have a total of 9. But this plus means that we have lost 1 electron. So even though we should have 9, we actually are going to have only 8. Okay, so one of these is going to be gone. So you have our 8 valence electrons. Once we have our total, then from here we can go to do some drawing. So we're going to let's take our N and our 4 H's and let's just put them around the N like this. Then we will connect up each one with a single bond. So 1, 2, 3, 4. Of these single bonds, to do this, we had to use 2, 4, 6, 8 electrons. Okay, so remember, each of these lines counts for 2 electrons. So we've had to use 8 electrons just to draw this out, and we actually only had 8 to begin with. So that means we have 0 electrons left. And so this would be our drawing for NH4. And then what we'll do to show the plus part is we're going to put this in brackets. We'll put the plus out like that. Okay. So this is essentially what we want to draw for number 6, is a molecule that looks like this. So not too difficult. All right, let's take a look at letter B for this. And again, I'll be flipping back and forth between our slides and my paper. So number 6, letter B, we have POCl3. All right, so again, we're going to do this drawing on paper. So let's switch back to our paper camera. Again, just make sure that we have this on frame so you can see it. Perfect. All right. So we have POCl3. So again, let's first count how many valence electrons we have. So we have phosphorus, which is in column 5. So that has 5 valence electrons. We have oxygen, which is in column 6. So there are 6 valence electrons. And then we have 3 chlorines. So 1, 2, and 3. So each of these, of course, is going to have 7 valence electrons because they're in column 7. All right, so let's count total number of valence electrons we have here. So 5 plus 6, so this is going to be 11. And then 3 times 7 is 21. And 11 plus 21 gives us a total of 32 electrons. Okay, so there's our total number of electrons is 32. So then from here, let's take all of these elements. Now usually, which element we want to put in the middle is going to be the one that is furthest to the left on the periodic table. Okay, so in this case, it's going to be phosphorus. So we'll put phosphorus in the middle. We'll put our oxygen and our 3 chlorine atoms around the phosphorus, okay, like this. So we always want to have one of these atoms in the middle. And again, whichever one we want to have is usually the one that has the least number of valence electrons. And then we will connect everything up with single bonds. So single bond, single bond, single bond, single bond. Okay, so we're going to have this so far. We've used 2, 4, 6, 8 electrons to draw these single bonds. So of our 32, we're going to minus 8. And so we now have, make sure we do our math right, 24 electrons left. So now these 24 electrons need to be distributed as lone pairs, and we're usually going to start with the outside atoms first. So let's start with the oxygen. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, right? That's 24 electrons. We had 24 electrons left. We just used all 24 of them to draw out all these lone pairs. And once we have 0 electrons left, that's it. We're done. That's our drawing. So this is our correct drawing for POCl3. Okay, and again, we would put this in our slides, but we're just going to do it on paper for right now. All right. So let's move on to the next problem here, number 7. It says, draw the electron dot structure of the polyatomic boron tetrafluoride anion. So they're giving us a chemical formula for this polyatomic ion, but it is BF4 minus. All right, so again, we're going to do this on paper. So let's switch our camera back to our paper here. Again, make sure we can see everything. Perfect, looks good. All right, so we have BF4 minus. All right, so again, let's start by counting our number of valence electrons. So we have boron, which is in column 3 on the periodic table. So again, I'm not using a periodic table. I just know this by heart, but you should find boron on the periodic table. It's in column 3. Then we have 4 fluorines, and each one has 7 valence electrons. Okay, so you have something like this. Now there is a minus. Okay, this minus means that we have gained 1 electron, which we'll count at the end here. So first off, we have 7 times 4, that is 28, plus the 3, so add 3 there. So this gives us a total of 31 electrons. Normally, however, remember that we are gaining 1, that's what the negative means. So we actually don't have 31 electrons, we have 32 electrons. Okay, so we have 32 total electrons. We need to draw this molecule. The boron, we're going to put in the middle, because again, whichever one has the least number of valence electrons is usually the one in the middle. So we'll put our boron in the middle. We'll take our 4 Fs and put them around the boron. So 1, 2, 3, and 4. Then we'll connect everything up with single bonds. So single bond, single bond, single bond, single bond. Of our 32 electrons, we've now used 2, 4, 6, 8 to make these single bonds. So we're going to minus 8. And we should have, let's make sure again we do our math right, 24 electrons left. And now we're going to start putting these as lone pairs, again, starting on the outside atoms. So we have 24 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that is all 24 electrons. We have 0 left. This is our structure. And then to incorporate this negative part, we're going to put this in brackets. And just put a little negative outside the brackets. Okay, that's going to show that this has a charge. So this is our correct drawing for BF4 minus. You know, very similar to the NH4 one that we had before, or the POCl3 one. So, all right, so let's go back to our slides. We have one problem left, and that is the last one, I think, problem number 8. So let's take a look. So it says, how many resonance structures, how many resonance forms can be drawn for CO3 2-? Show the electron dot structures for each. All right, so we're going to have to do some drawing again, and this is going to include some resonance structures. So this is, again, where I'll show you how the resonance thing comes into play. So what we're going to do is we're just going to draw CO3 2- first. Then we're going to take a look and see, is there any other way that we can do this? So first, let's again count our total number of valence electrons. So we have carbon, which has 4, and we have 3 oxygens. Each one has 6, because oxygen is in column 6. Okay, now we have this 2- here, which means that we've gained 2, which we will take into account at the end here when we're counting. So we've got 6 times 3, that is 18, plus 4. So this gives us a total of 22 electrons. And then, of course, we got to add in the fact that we have 2 more. So not, instead of having 22, we're actually going to have 24 electrons. Okay, so this is the total number of electrons we have is 24. All right, so then from here, we're going to draw our first structure. So let's draw carbon in the middle, okay, because that has the least number of valence electrons. We'll draw 3 oxygens around it. So let's go 1, 2, 3. Then we'll bond it up. So single bond, and single bond. of our 24 electrons, we've just used 2, 4, 6. We've used 6 of them. So we're going to minus 6 electrons, which means now we have 18 electrons left. Now we're going to start putting lone pairs. So starting on the oxygens on the outside, we have 18 total to distribute. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now that's all 18 electrons. We have 0 left. However, this is not a good structure. And the reason why it's not good and it's not done yet is even though we've used all of our valence electrons to draw this, this carbon in the middle does not have 8 valence electrons. It only has 6. So we are breaking the octet rule right now. Okay, so what we can do to fix this is we can take one of the lone pairs on the oxygen atoms, any of these 3 oxygen atoms, and put it as a bonding pair. So let's take this bonding pair, or this lone pair, and put it as a bonding pair. So we have a double bond here. Okay, so basically what this is going to look like is we'll have a carbon with a single atom to our oxygen up top, a single bond to our oxygen on the right, and a double bond to this oxygen here. Okay, and again, our lone pairs are still going to be there. So this is what our structure is going to look like. It's going to look something like this. This is our first resonance structure. Okay, and in a resonance structure, again, is we can draw this in more than one way. So in this example, I chose to take the double bond and make it over here. However, I could have also decided to take one of these lone pairs and make the double bond up off the top. So I could have done it. Sorry, kind of messing up my drawing here. I could have done it this way and made it like this. Okay, double bond up off the top rather than off to the left. Or lastly, I could have decided to make the double bond with the oxygen on the right. So that is our third way that we could have drawn it. And so this is what we call resonance, is where you have essentially the same molecule, but you can draw it in more than one way. And this is one prime example where that double bond can be in 3 different locations. And again, you might be thinking, well, I mean, aren't we really just like rotating this in a circle, right? I mean, isn't this just the same thing as this, only we just turned it like 90 degrees or 45 degrees or whatever? No, okay? Again, if we number these atoms, like, you know, oxygen number 1, oxygen 2, oxygen 3, the double bond is between oxygen 1 and the carbon. And over here, it's between oxygen 2 and the carbon. And again, it might look like, well, all we've done is rotate it, but if we actually number these oxygen atoms, we'll notice that the bond is actually between a different oxygen atom and the carbon atom, okay? So either way, this is what we call resonance, and ultimately the question was asking, well, how many resonance structures can we draw? 3, okay? In this example, we can draw 3 resonance structures for CO3 2-. All right, guys, so that is it for this section of notes and these practice problems. Hopefully that helps you. But again, if you ever have questions, make sure that you just ask, send me an email, reach out through, maybe reach out in class, or we can always do a Google Meet and do some practice, okay? But it's important that we do some practice drawing these things out because, again, this chapter section can get challenging, and the drawing part is by far the most challenging part. So, all right, that's it for this one. I'm Mr. B. Thanks for watching, and I'll see you in the next one. Bye.